Okay, so the first paragraph there talks about arithmetic versus geometric sequences. And so just to kind of recap for you, and you might want to write this down, arithmetic sequences add or subtract the same number. Okay, and that's how the sequence is formed. Geometric sequences multiply or divide. We never really think about it as division with these. We'll just think about it as multiplying by the reciprocal, but they multiply or divide by a number. So for example, if you see a sequence and it looks like it's being divisible by 2, it's being divided by 2, divided by 2, divided by 2. Instead of saying it's divided by 2, we talk about it being multiplied by 1/2. Okay, so you always kind of talk about it in terms of what it's being multiplied by. You could have a sequence that is neither of these, where it has a pattern but it doesn't fit, geometric or arithmetic. Okay, and then at the bottom they talk about it being finite or infinite. So a finite series stops at some point, and infinite just goes on forever. Okay, so here it says determine the sequence of numbers or pictures, whether it's arithmetic or geometric or neither, and then identify what's either being added, which is what we call the common difference. So this is what's being added or subtracted, or the common ratio, what's being multiplied. Okay, finally circle whether it's infinite or finite. Okay, so let's look at this first picture. They want you to figure out based on the number of tiles. Okay, so if I look at the number of tiles here, I have 9 tiles to start, and then I have 12, and then I have 15, and then I have 18. Okay, so when we look at those numbers, 9, 12, 15, 18, would that be an arithmetic sequence or geometric? Arithmetic. Good. Arithmetic, because what are we adding to it each time? So D equals 3. Okay, every time it's going up by 3. Could this pattern conceivably go on forever? Yeah, so this is an infinite sequence. Okay, the second one is the number of toothpicks. So each line represents a toothpick. So for example, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we're starting with 12. And then it looks like we add 10 to that, so 22, and then 30. Okay, so we go 12, 22, 30. Are we adding the same number each time? No. Are we multiplying by the same number each time? No. Okay, so this is a neither sequence. Would this pattern conceivably be able to be continued forever? No, right? Because eventually it's going to hit like that top and you're not going to be able to add anymore. So this is what we call a finite sequence. Okay, eventually it's going to stop. You can't go any further. Okay, flip it over. This first one on the back says the number of rows. So we're talking about how far back this thing is going. Okay, and so we have 1, 2, 3, 4. So is this arithmetic or geometric? Arithmetic, D being what? 1. Could this conceivably go on forever? Yes. Okay. This one's a little bit tougher because they're asking for the number of cubes involved in the whole picture. So we have 1, and then how many are in this next one? You have to count all of them. Good, 6. So not just the ones you see, but the ones that would be there to make that picture. And then see how you have to count all of them? So 15. There might be more than that. Let's see, 3. So 1, 2, 3, 4, 5, 6. Yeah, so I think there's 18, right?
Yeah.
Because there's 3 per row, per line, and there's 6 lines there. 40, yeah. Okay, so when we look at 1, 6, 18, 40, is there some sort of pattern? Are we adding the same thing or multiplying by the same thing?
No.
No. So neither. And again, this one could potentially go on forever if you just keep adding to it. Okay. I want you guys to do the next two. Okay, so just the ones with the triangle, and that triangle should look kind of familiar to you since you formed it yesterday.
Yesterday we took the SAT.
Oh, 2 days ago. You're right. Man, I'm off again. Not even opening the door and having my days wrong, huh?
This one be an infinite. When this one be?
The two big one?
Yeah.
Because eventually you're gonna reach the top, and then you can't draw anymore. So eventually you're gonna get to here, and you can't like stack that way or anything, right? It's not today, probably tomorrow or something. You're gonna get a pass today, saying what day it is. Because we're looking for first or fourth period. It doesn't matter. How did you part? That's something we don't.
You're so white.
Tomorrow I wish I could give you an option. I can't.
What's weird about this place? It'll be snowing one day and then 60 the next day.
But eventually
I'm
you're
from Illinois, but weather is different.
there's nothing wrong.
81.
Really?
Oh.
I want to live in the city.
But if you're starting with this tree, you're gonna tear it down. You're not gonna make it. Okay, so what's happening is
Cali's.
I guess there is a fun. Life's better over there. That's not what I was thinking.
so remember when you were drawing that out? Way back when? Like you were like, oh, mid-second,
Yeah,
so you're gonna need that. You're gonna get to a
I've
point
been
where
there.
like that's gonna get impossible.
Okay, so in this first one we have 3, 9, 27, 81. So this is geometric. We don't use D for geometric, not that you guys knew that yet. We use R, and so if you put D, that's fine. R is equal to 3, and technically this could go on forever, although your triangles would be like so tiny you probably couldn't see it. Okay. Okay, and then F said the number of white triangles, so now we have 1, 4, 13, and 40. Is there any sort of sequence going on there? So there's not geometric or arithmetic. Technically, again, they could go on forever, although eventually it's probably just going to look like one big white triangle there. Okay. Okay, we'll skip the next two. So it says create your own sequence with the given type indicated. Include the first 3 terms. Okay, so go ahead. Why don't you do arithmetic and geometric? You don't need to do the neither one. So just do the arithmetic and geometric. Make your own one up. It can be a picture one. It can be a number one. Okay, who wants to go up there and write their arithmetic sequence up there? Who wants to tell me their arithmetic sequence then? What did you do?
I just D + 1.
Okay, and so what was your sequence?
I just started with 1,
1, 2, 3, 4. That's a good one. Okay. Anybody have a different one? You want to share? Okay, what about geometric? R equals 2. What was your sequence? 1, 2, 4, 8, so forth. Yep, good. Okay, we understand that, so flip it over. Okay, it says 2 types of formulas. Previously, you learned the explicit and recursive formulas for arithmetic and geometric. You guys probably haven't, but they're here. Okay, an explicit formula for a sequence is a formula used to calculate each term based on the term's position in the sequence. And the recursive, you need to know the previous term. So, as we were doing the project 2 days ago, a couple of you said like, oh, the pattern is just multiply by 4, multiply by 4, multiply by 4. Okay, and I probably said something to you like, that's great that you can find the pattern, but what if I said like, I think that was the flu problem. So like on the 100th day, how many people have the flu? Well, then you'd have to keep multiplying by 4 all the way to the 100th term. And so what the explicit formula does is it writes like a rule that we can just plug 100 into, so we don't have to keep multiplying every time all the way through. Okay, and so it's a really important thing that we can write this rule so that we don't have to sit there forever and calculate over and over again what's happening. Okay, so these are the 2 main formulas that we're going to be working with for the next couple days. We will always give you the formula on the test, on the quiz, on the final. Okay, you don't have to memorize the formula, but you do need to know what all the pieces of the formula mean, because otherwise you don't know how to plug into it. Okay, so a sub 1 is going to be the first term. And it says that on there. Okay, so we got a sub 1 is the first term. Okay. D, we already went over, is like the common difference. What are you adding or subtracting to get to the next term? N is the term position. So where is it in the sequence? Is it the first term? Is it the second term? Is it the 100th term? That's N. Okay, geometric kind of works the same way. G of 1 or A of 1, those will be used interchangeably. So if you see something with an A sub 1 here, that's okay. It's the same thing. It's the first term. R is the common ratio. So what are we multiplying by to get to the next term? And then N is the term position again. We're not going to work too much with the recursive formulas because the recursive is just like take the previous term and add the D or R to it, or multiply by R. Okay, so that's not really all that difficult to do the recursive formula. Okay, so let's look at number 1, and it says, I'll show you the recursive formula the first time, but we'll just do mostly the explicit formulas. Bless you. Okay, so if the sequence is 9, 12, 15, 18, first of all, is this arithmetic or geometric? Arithmetic, okay. Because I'm adding what? I'm adding 3, so D is 3. Okay, so when it's the recursive formula, all you have to do is take the term that you ended on and add 3 to it to get the next term. Okay, so what would the 5th term in this sequence be? 21. Okay, you just do 18 plus 3 and get 21. So that's not super difficult. But again, that's not very useful if I said find the 100th term in this sequence, because then you have to keep adding 3 all the way to the 100th term. So the explicit formula allows us to find any term in the sequence without knowing the previous term. Okay, and so I'm going to plug into this formula that's up there, so I'll write it again. AN equals A1 plus D times N minus 1. And I would suggest, like, at least for a while in this chapter, you write out the formula every time. Because then you can just look at the formula and plug in the pieces that you know. Okay, you're not trying to come up with it from scratch. So, I don't know AN. That's going to be the term that I'm looking for, any term. Do I know the first term in the sequence? It's 9. Do I know D, what it's changing by? It's 3. And then I don't know N, because that's the term position, and I want to write a rule that works for any term position. Okay, so I'm going to leave it like that. So we're going to distribute the 3 and just kind of simplify this down. So 9 plus 3n minus 3, or an equals, add the 9 and the negative 3 together, and what does that give you? So we got 6 plus 3n. This rule will generate any term in the sequence. Okay, any term in the sequence. So like if I want this first term and I plug in 1 here for the first term, do I get 9?
Yeah.
Yeah. If I want the second term and I plug in 2 here, do I get 12? Yeah. If I want the third term and I plug in 3, I'm going to get 15 and so forth. Okay, so that's why this rule is so important, because I can generate any term. So now if I asked you for the 100th term, you just plug in 100 and you have the 100th term. And you don't have to keep adding 3. Yep. Sure. Yeah, it doesn't matter what order you put that in because they're being added. Okay, so now if I ask for the 5th term here and you plug in 5, what do you get? 21. You get the same thing. Okay, so this is the general rule, and we're still getting 21 as the 5th term. So A5 would be 21. Okay, questions? There. Okay, let's do one that is geometric. Just to practice, I think this got cut off, but it was 81 as your last number. Okay, so first of all, this is geometric. And what is r equal to? What am I multiplying by? 3. Okay, I'm not going to worry about the recursive formula, so let's go to the explicit formula. When I looked up at the formula, it says that, and I'm just going to change them to a's so you don't get confused. So an equals a1 times r to the n minus 1. That's the geometric formula from up in the boxes. Okay, so I don't know an. That's the term that I'm going to be looking for. Do I know the first term?
Yes.
3. Do I know r? 3 to the n minus 1. Okay, so this rule generates any term in this sequence. You plug in the term position for n, it pops out the term that you have. So if I want the 5th term in this sequence, I can just say A5 is 3 times 3 to the 5 minus 1. Now you have to be careful when you plug this in your calculator. You know, you have to like kind of put this whole thing in parentheses over here, okay, to make sure that it's right. So really this is 3 times 3 to the 4th. Okay, so go ahead and do that. Figure out what the 5th term is. You should get 243, so make sure you can get that. Try it. You want to make sure you're like typing it in right, because if you're typing it in wrong the whole rest of the chapter, you're going to be typing it in wrong. Good? Everybody able to get 243? Okay, so let me ask you this question. Which formula do you think you'd want to use to determine the 95th term of either sequence? So do you want to use the recursive formula or the explicit formula? Explicit, right? Because then you can just plug 95 in and you don't have to generate all 95 terms before you get that, or all 94 terms before you get the 95th, okay? Hopefully you see the benefit in creating the rule. Okay, so on the next page, it says identify each sequence as arithmetic, geometric, or neither. If possible, determine the 50th term in each sequence. Okay, so in this first sequence, look at it a little bit. See if you can figure out, is it arithmetic or geometric? What do we think? It's arithmetic. And we know this because we should have D then. What's D equal to? 4. Could D possibly be a negative number at any point? Sure. If your sequence is going down, decreasing, then it would be negative. Okay, so D is 4. And we want to find the 50th term. So I am not going to sit here and add 4 all the way to the 50th term. I'm going to write the rule. Okay, and so again, I'm going to write out the formula. AN equals A1 plus D times N minus 1. And we'll give you that. Okay, you have to know that's arithmetic, and you have to know what all the pieces mean. So AN, I don't know. That's the term I'm looking for. A1, do I know the first term? -5. Do I know D? 4 to the N minus 1. Okay, so I'm going to simplify so I have a general rule, and then I can plug in 50. Okay, so AN equals -5 plus, I distribute the 4, 4N minus 4. And then combine your like terms. So AN equals -9 plus 4N. That's your general rule. That's going to generate any term you want. And what term do I want? 50. So how do I find the 50th term? Plug in 50 for N. Okay, so that means that A sub 50 would be equal to -9 plus 4 times 50. Okay, well that's 200 minus 9, so 191. Okay. Questions? Okay, part B. What's the pattern here? Add 1, stay the same. Add 1, add 1, add 2. Is there any sort of pattern happening? No. Okay, so this is a neither type sequence. Would it at all be possible to find the 50th term? Yes, if you can see the pattern up here, but we're not gonna. I won't make you find the 50th term because it's hard to do. Anybody see the pattern that's happening here? It's a special thing in math.
It's like so like 3 minus 2 is 1, and then 2 minus 1 is 1.
Good. Okay.
And
Yeah,
that's
you're
0.
good. You're describing it a little bit backwards, but it's correct. Okay. So when you add the two previous terms, you get the next term. So 0 and 1 is 1, 1 and 1 is 2, 1 and 2 is 3, 2 and 3 is 5, and so forth, which is the same way you were describing it. You were just subtracting. Okay? So that is a kind of a special pattern, but I would never make you generate the 50th term for that pattern because there's no way to write a rule for it. Okay? And so we won't have to do that. Okay, C. This is an important example for you. So let's look at this one. What's happening here? Okay, so it's being divided by 3. And so it's definitely a geometric problem. But instead of saying it's being divided by something, I want to know what it's being multiplied by. Because R always has to be what you're multiplying by. 1/3. Good. Okay, so we're multiplying by 1/3. Oops, sorry. You can write that there. So geometric, R is 1/3. Okay, so I'm going to write the general rule is AN equals A1 times R to the N minus 1. Okay, so AN equals, what's the first term? 27 times 1/3 to the N minus 1. Okay, that's your general rule. There's no real like simplifying or anything you have to do. How do I find the 50th term then? Plug in 50 for N. Good. Okay, be careful on your calculator when you do that. So A sub 50 equals 27 times 1/3 to the 50 minus 1. Okay, I got like some scientific number. It's like real small, so like 1.13 times 10 to the negative 22nd or something. You should see like off to the side. It tells you like to the negative 22nd power. So it's real small. Any questions on getting that? Okay, very good. Use either the recursive formula or the explicit formula to determine each answer. Okay, and so in this one, it says the sum of the interior, you guys have this from, right? The sum of the interior angles in a triangle is 180 degrees. In the quadrilateral is 360, and in the pentagon is 540. How many degrees are there in a decagon? Okay, so first of all, this one's a little bit of a tough problem, so I'm going to kind of write out your 10 terms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Does anyone know why I'm doing 10? Good. Deck has 10 sides. Okay. And so you can label your terms 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And they're saying that we're going to first start with a 3-sided figure. So we have 180, okay, and then 360, then 540. Okay, is this sequence arithmetic or geometric? Okay, it's arithmetic. So you might think it's geometric because you're like, oh, I'm multiplying by 2, but you don't multiply by 2 to get to this one. So it has to continue. So it is arithmetic, and we know that because I'm adding what? 180 every time. Okay, so D is 180. Okay, let's see if we can write the rule then. And so again, I will write out the general equation. Bless you. Okay, and so we have AN equals A1. Do we have the first term? What are we starting at? 180 plus, what's D? 180 times n minus 1. Okay, so I'm going to distribute the 180. AN equals 180 plus 180n minus 180. So what does the general rule end up being? 180n. Okay. And that should make sense to you. So here's your general rule. Now, the kind of tricky part of this problem, and this is like definitely an SAT type question, because we don't want to plug in 10. Okay, and so anyone know why we don't want to plug in 10? What did we start with a one-sided figure? No, how many sides does this have?
3.
So 3, 4, 5, 6, 7, 8, 9, 10. So the 8th term in this sequence is your decagon. So what do we want to plug into this?
12.
The 8th term. So you want to plug in 8, right? So A8 actually is your decagon. Because the n is not representing the number of sides, it's representing the term number. Okay, and so we get 1,440 degrees. Okay, and so that's kind of the tricky part of this problem, is like you probably most likely most of us would want to plug in 10. Okay, but it's not the 10th term, because you can't start with a figure that only has one side as a line. Okay, it's not going to have any degrees in there. Any questions there? Okay, we're going to skip this part B one. Is that it? Okay, very good. I want to give you a chance to kind of start your homework today so you can ask